Okay, let's continue our discussion on the topic clock problems. So we're going to solve this third problem of the clock problems. So the third problem says find the angle between the hands of the clock at 3:43 p.m. Okay, so this is the problem. So we're given the time here 3:43 p.m. So let's draw the initial position of the hands of the clock. So initially, the minute hand or the hour hand is pointing towards 3. And minute hand pointing towards 12. So that's the initial position. That's 3 o'clock. Okay, so after some times, we're given here at 3:43 p.m. So where is 3:43? So of course, if 3:43, this hour hand is no longer pointing 3, right? So where is now the minute hand? 3:43. So 43 minutes later. So where is it? So this one, this is 5, 10, 15, 20, 25, 30, 35, 40. So 43 minutes. So somewhere between 9 and 8. Okay, so you can just approximate. So let's approximate that this is the position of the minute hand. So therefore, the minute hand travels from this initial position, okay, up to this final position. Or a reference position. So this is the distance traveled by our minute hand, which is equal to 43 minutes as given in the problem. Okay, and then initially at 3 p.m. So this is the position of the hour hand initially. So initial position of the hour hand, which is equal to 15 minutes. That's 15 minutes because every number there that corresponds to 5 minutes. Okay, and where is now the position of the hour hand? So the hour hand initially pointing towards 3, but now it's no longer pointing towards 3. It should be between 3 and 4 because 43 minutes is not yet 1 hour. So it means that the hour hand didn't reach yet the 4. So approximately somewhere here. And we know that as the minute hand travels x distance, there is a corresponding distance traveled by the hour hand, which is x over 12. Okay, but we're given our x here is equal to 43 minutes. So therefore, this is 43 divided by 12. And now, what's the distance between the hour hand and the minute hand? So this is the distance. Okay, so we don't know that. So we can represent that as any symbol. But the angle between the minute hand and the hour hand, we can designate that with any symbol. So angle, we can use theta, alpha, beta. So it's up to you. So we can call that as theta. So if this is theta in terms of degrees or angle, this is also theta in terms of minutes. So this is also theta. So similar to our first two examples, we just equate the total distance traveled by the minute hand with the small distances Okay, so the total distance traveled by the minute hand is equal to 43. Okay, so equal to 43. And this is equal to the sum of these distances. We have 15 minutes. Okay, we have 15 minutes. Then plus, we have 43 over 12. Then plus, we have this distance which is theta. Okay? So, solving for theta, we just transpose this 15, positive 15 to the other side, and also this positive 43 over 12 to the other side. So, theta is equal to 43. So, when we transpose, the sign becomes negative. So, this is positive, no sign that you can see. So, understood to be positive. When you transpose that one, that becomes negative. So, this is positive, so that is minus 43 over 12. So, combining, we have 43 minus 15, that is 28, minus 43 over 12. Okay? Then, finding the LCD on the right side, the LCD here is 12. This one understood to be over 1. So, 12 divided by 1 is 12 times 28. So, 12 times 28. Then minus, so this is also minus. 12 divided by 12 is 1 times 43 equal to 43. So theta therefore is equal to, when you calculate that one, so this gives us 24.41 minutes. Okay? So that is in minutes, but we are asked to find the angle. So to find the angle, we have to use the principle that we have discussed earlier at the beginning, in the first video or second video, that one revolution is equal to 60 minutes. Okay? And in terms of angle, one revolution is equal to 360 degrees. Okay? So now if we want to get our angle in terms of degrees, what we need to do is you just use this concept or this facts or this relationship here. So 24.41 minutes. Okay, I'll just abbreviate to min. Just multiply this by 1 minute is equal to 1 revolution. So 1 revolution, we'll just abbreviate this as rev divided by 60 minutes. So that is what is meant by this. 1 revolution is equal to 60 minutes. So 1 rev is to 60 minutes. Then multiply this, we have another 1 revolution, 360 degrees. So we can also say 360 degrees divided by 1 revolution. Okay? Now we have units. Oh, by the way, this is multiplication of fractions. This one is understood to be over 1. So the rules in multiplication of fraction is multiply the numerators, multiply the denominators. So in the numerator, we have unit in minutes. In the denominator, we have unit in minutes. We have unit in the numerator in revolution. Denominator, we have revolution. Okay, so that cancels out. So what is left here is 24.41 times 1 times 360 degrees divided by 1 times 60 times 1, or that is 60. Okay, so the unit left is only degrees. So therefore, our angle is equal to, use our calculator to calculate that one. So this is equivalent to 146.46 degrees. So this is the angle between the two hands, the hour hand and the minute hands. Hour hand and minute hand. So this is the answer. Okay, so I hope you understand this one. And you can solve this also using the ratio and proportion. So by ratio and proportion, this is another solution. By ratio and proportion. So we have this angle in minutes. This angle in minutes, theta in minutes, which is equal to 24. So 24.41, this is in minutes, divided by theta in minutes. So this cancels out, equal to 360, no? 360 this is 24.41 minutes divided by 60 minutes equal to theta in terms of degrees divided by 360 degrees. So you solve algebraically, you get theta, same answer, 146.46 degrees. So that is using ratio and proportion. So what does it mean? We have the minutes, in terms of minutes, this one. We divide it, this is just the portion of one complete revolution, which is 60 minutes. So this is the number of minutes, which is equal to 24.41. Divide of the total minutes in complete revolution, which is 60. Then in terms of angle, so this angle theta, divide this by the one complete revolution, which is equal to 360. So this is the ratio and proportion. So theta, therefore, solve it algebraically, we get 146.46 degrees. Okay, same answer. Okay, so that's all. Thank you very much. If you have any question, just leave your question, your comments in the comment section. Bye.